This is OwlUp, where learning happens in minutes, not hours. For a deeper journey, explore all our courses at owlup.co. Now, let's dive in. Welcome back to Chapter 4 of our series, Quantum Computing for Innovators. In this episode, titled Applications in Real-World Quantum Computing, we'll explore the exciting ways various industries are tapping into the power of quantum technology. Get ready to discover how this groundbreaking field is transforming sectors from finance to healthcare and beyond. Let's dive in. A taxi in Lisbon moves off the curb, not because a human dispatcher gave the signal, but because a quantum processor suggested the route. In another lab, a drug molecule's behavior is predicted by hardware that still makes plenty of mistakes, yet already outperforms classics. Those Lisbon taxis and drug simulations are early hints of a deeper shift. Quantum is quietly slipping into real business workflows, not as a replacement for classical computing, but as a specialist brought in for the hardest parts of the job. The pattern is emerging across industries, small noisy devices solving narrow but painful bottlenecks. A bank doesn't run on quantum, but it may use a quantum subroutine to prune a vast portfolio search. A logistics firm still plans fleets classically, but feeds its ugliest routing core into a quantum optimizer. In this episode, we'll zoom in on three live fronts: optimization at city and supply chain scale, chemistry and materials for next-gen drugs and batteries, and machine learning where training time or data scarcity is the blocker. Our goal? Translate these pilots into a practical question for you. Where in your domain do similar hard kernels hide? Think of today's quantum pilots as quiet specialists embedded inside ordinary systems. They rarely own the whole workflow, but they reshape what's possible at the toughest knots. Banks now benchmark quantum tools on portfolio construction with thousands of constraints. Grid operators test them on balancing renewables when forecasts swing wildly. Manufacturers probe scheduling on lines where retooling costs a fortune. Across these tests, the pattern is similar. Identify a tiny region where decisions explode combinatorially, then see if quantum can carve through that thicket faster or deeper than your best heuristics. A 17% drop in taxi idle time sounds modest, until you apply the same idea to aircraft sitting on tarmac, trucks stuck at depots, or high-value engineers waiting on test benches. The frontier right now isn't sci-fi scenarios. It's shaving painful inefficiencies off very specific, very expensive decisions. In mobility and logistics, the hotspots are problems like dynamic routing, cargo loading, and crew scheduling, all under uncertainty. Here, companies map their toughest decisions into forms such as QBO or constrained optimization, then send those to hardware like D-Wave's Advantage or IBM's gate-based systems. The quantum result is rarely plug-and-play. Teams wrap it with classical pre-processing to select the most relevant variables and post-processing to clean up or further improve candidate solutions. The win comes when that hybrid loop uncovers options a human or greedy heuristic would never consider in the available time. In pharma and materials, the focus shifts. Instead of squeezing trucks and shifts, the target is the complexity of electrons in molecules and solids. Workloads like the ground state energy estimate Roche reported are stepping stones toward tasks your R&D leaders care about directly. Screening candidate drugs for binding affinities, predicting side effect profiles earlier, or exploring new battery chemistries before committing to costly wet lab campaigns. Here, variational algorithms and error mitigation tricks are tuned to get chemically useful answers from imperfect devices, then fed into existing simulation and discovery pipelines. In finance and energy, quantum pilots probe portfolio construction, risk aggregation, and grid balancing under volatile renewables. The pattern repeats. Encode the nastiest combinatorial core, co-design it with domain experts, benchmark ruthlessly against classical baselines, and only then consider scaling. Architecturally, think of these deployments as adding a specialized quantum wing to an existing building. You don't demolish your data centers, you add a new, purpose-built hall for a handful of extreme workloads and connect it via well-designed corridors of software, APIs, and governance. Your challenge this week. Pick one concrete decision process in your organization that 1. Explodes in complexity with scale, 2. Runs frequently, and 3. Materially affects cost, risk, or revenue. Don't ask, can quantum do this, yet. Instead, map the decision as a pipeline. Data sources, constraints, objective, current heuristics, runtime, and pain points. Then, highlight the single substep where the search space feels most unmanageable. Too many combinations, too many scenarios, too many couplings to model cleanly. That highlighted kernel is your first candidate for a quantum-ready workload, even if you never touch a qubit this year. A sportswear brand tests quantum tools on retail layout. Which products go where? Which mannequins get which outfits? How to rotate displays weekly without confusing regulars. They encode the decisions, feed them to a solver, and discover patterns, like niche items that quietly boost basket size when placed near returns, that human merchandisers missed. A wind farm operator explores maintenance scheduling. Dozens of turbines, weather windows, vessel availability, safety rules. Classical tools already juggle these, but a hybrid quantum approach surfaces non-obvious groupings of tasks that cut downtime while respecting every constraint. In cybersecurity, a payments company experiments with quantum-resistant key management policies. They're not breaking RSA. Instead, they simulate migration paths. Which systems to upgrade first? How to stagger certificates? How to minimize customer disruption? One analogy, it's like redesigning an airport while flights still operate. Phased gates, temporary corridors, no room for a full shutdown. So sequence matters as much as the final design. Early pilots hint at a deeper shift. Strategy becomes less about guessing which bets pay off, and more about orchestrating many small, fast experiments across messy decision spaces. Think of it as upgrading from static roadmaps to live traffic maps for your business choices, where routes update as conditions change. As tools mature, advantage may flow to teams that treat quantum not as a magic answer, but as one more sharp instrument in a constantly evolving decision lab. Treat today's pilots less like final products and more like early prototypes in a new materials lab. You're testing what bends, what breaks, what unexpectedly shines under stress. As tool chains harden, the leaders won't be those who bet on a single killer app, but those already fluent in mixing quantum into messy, evolving decision recipes. Before next week, ask yourself, 1. If I had free access to a small real-world quantum processor, like IBM's or Rigetti's cloud machines, what single concrete problem from my own work or interests, route optimization, portfolio risk, molecule simulation, fraud detection, would I actually try to model? And which parts of that problem map naturally to qubits, superposition, or QAOA VQE style algorithms? 2. Looking at the hardware limits they mentioned, noise, decoherence, shallow circuits, which one step of my chosen problem could realistically be turned into a near-term hybrid quantum, classical workflow, for example, using a quantum subroutine for combinatorial search while keeping the rest classical? And what tools or SDKs, Qiskit, Cirq, Pennylane, would I explore today to sketch that out? 3. If I had to explain to a non-technical teammate tomorrow why our problem might not yet benefit from NISQ-era quantum machines, which specific constraints from the episode, error rates, qubit counts, connectivity, scaling of circuit depth, would I point to, and how would that shape the timeline and expectations for any pilot we might run? This was OwlUp, your daily step forward. This series continues with more chapters on OwlUp.co. Visit OwlUp.co to access the complete course and continue your learning journey. See you there!